Welcome to the debate. When you step into the cockpit of a modern commercial airliner, you aren't really flying the plane for most of the journey.
Right. You're interacting with an abstraction layer.
Exactly. The autopilot handles the minute aerodynamic adjustments, the altitude, the thrust, the navigation. We accept this because human reflexes simply cannot process the sheer volume of telemetry data required to keep 300 tons of steel in the air safely.
But the pilot still fundamentally needs to know how the physical plane interacts with the air. Because when a sensor freezes over at 30,000 feet, or the automated system hallucinates an obstacle and abruptly dives, well, the human has to take the stick.
Right. They have to intervene.
Yeah. If they spent their entire career just pushing buttons on a shiny glass screen and they've forgotten the basic physics of aerodynamics, that plane is going down.
And that exact tension is what brings us here today. We are looking at a critical analysis for developers and cloud professionals regarding this rapid integration of automation. Specifically, the massive wave of artificial intelligence tools that have completely taken over the IT sector in 2026. We have to ask a really difficult question. Where exactly is the boundary between highly productive automation and, a dangerous, excessive dependence on AI?
I'd argue it is the defining technical question of our time. If you're listening to this and you're a DevOps engineer or a sysadmin or a full stack developer, you are living this reality every single day.
Absolutely. So today's debate emerges from recent industry analysis, which includes insights from MIT Sloan experts, Swati Gupta and Rama Ramakrishnan. Plus, we're looking at a comprehensive 2026 guide detailing 20 types of active AI tools deployed across the tech sector.
Yeah, it's a massive shift.
It really is. I argue that these AI tools represent an essential, democratizing force of productive automation that quite literally makes IT professionals superhuman.
And I argue that blindly relying on these tools fosters an excessive dependence, risking massive systemic vulnerabilities, widespread technical inaccuracies, and a critical loss of foundational engineering understanding.
Look, from my perspective, automation through AI in the IT sector is a necessary evolution. It's not a crutch. We really have to look at the sheer scale of modern IT demands.
Okay, but scale doesn't mean we just abandon the basics.
Sure, but the days of a few sysadmins manually monitoring physical servers in a basement, those are over. Modern infrastructure is incredibly complex. Human teams can no longer manually manage multi-cloud costs or monitor millions of asynchronous network events.
Well, the scale is larger, yes.
Right. And no one can write complex YAML configurations at the speed the global market requires today. The data from 2026 shows us that tools like Amazon Code Whisperer, GitHub Copilot, and Dynatrace are taking over the heavy lifting.
Taking over is putting it mildly.
But this is about leverage. We are abstracting away the manual drudgery so that the human mind can focus on high-level architecture.
Well, I don't disagree that these tools offer unprecedented speed, but the tech industry is crossing a perilous line here. We are routinely mistaking speed for engineering rigor.
How so?
MIT Associate Professor Swati Gupta has explicitly warned about generative AI models carrying inherent inaccuracies. When developers rely on an AI tool to automatically optimize databases, or when they write SQL from plain English prompts, we have to look at what's actually happening under the hood.
They're translating semantic intent to code.
No, they aren't structuring the queries themselves. The AI is mapping their semantic intent to a database schema, guessing the joins, and just outputting text. They are replacing deep, necessary system understanding with blind trust.
Okay, I wouldn't call it blind trust.
It is blind trust in a tool that is merely generating probable text based on statistical distributions. When the system breaks, and it always breaks, the engineers won't know how to fix it because they never truly built it.
Okay, I want to dig right into that idea of the engineering core, specifically regarding code generation.
Please do.
If we look at the landscape of AI coding tools right now, like Cursor, Tab9, Replit AI, these are no longer just the simple autocomplete features we had a few years ago. They sit right inside the code editor.
Right, they're entirely embedded.
Exactly. They analyze your entire surrounding context, they complete entire complex functions, and they explain cryptic bugs in real time. The way I view this, it is exactly like having a senior developer sitting next to you at all times.
A senior developer?
Yes, it's an unparalleled mentor that actually accelerates learning for junior developers because they get perfectly tailored examples for the exact problem they are trying to solve.
I'm sorry, but I just don't buy that. Let me tell you why.
Go ahead.
That analogy completely falls apart when you look at how human learning actually works. A senior developer teaches you foundational understanding. If you pair program with a senior engineer, they stop you and ask, why did you choose this specific design pattern?
Well, sometimes, sure.
Or they say, are you sure this is the most efficient way to manage memory here? An AI tool doesn't do that. It simply outputs the compiled code and says, here you go. The human mentor teaches you how to think, whereas the AI teaches you how to copy.
But doesn't the output itself serve as a learning tool? Like, if I am a junior developer and I see an elegant, highly optimized block of code generated by Copilot, I am exposed to a better way of writing.
Maybe.
A way I might never have discovered by just, reading static documentation.
You are exposed to a statistically probable way of writing that is not necessarily the optimal or secure way. I'll admit, the first time I used an LLM to write a complex regex pattern, I felt like a wizard.
Right. It feels like magic.
It saved me 45 minutes of staring at documentation. But 3 weeks later, when that regex broke in production and started dropping user data, I had absolutely no idea how to fix it.
Because you didn't manually write it.
Because I never understood the underlying logic in the first place. What we are seeing in 2026 is the creation of a massive dependence where freshers learn how to prompt rather than how to program.
Well, I think you are underestimating the adaptability of modern developers. They aren't just blindly accepting code, they are reviewing it.
Are they?
Yes, the AI acts as a pair programmer, providing a really solid first draft. It removes the friction of syntax.
But that assumes the developer has the requisite expertise to properly review that first draft. To quote Rama Ramakrishnan directly from the MIT Sloan Analysis, it's a lot easier to collect data than to collect understanding.
That's a fair quote.
These models collect and regurgitate data. They don't understand it. We are building an entire generation of developers who treat their own code base like a black box. If an AI writes a multi-threaded asynchronous function and the developer just hits accept, that developer is functionally illiterate in their own application.
But be realistic for a second. Are you actually suggesting teams go back to manually writing every single line of boilerplate code?
Not every line of boilerplate, no.
Because if you are, those companies will be out-innovated and bankrupt by next Tuesday.
Even if a developer misses a bug in their own code, it's not just sitting on a local machine anymore. It goes to the cloud, which makes the risk worse.
No, that's where AI shifts from being a helpful mentor to an absolute survival mechanism. Let's look at DevOps and cloud computing tools like AWS AI, Azure AI, or Harness AI. Automation here isn't just a convenience, it is non-negotiable.
I agree that the scale of telemetry is beyond human capacity.
Exactly. Modern distributed systems generate millions of telemetry events per second. A human being cannot sit there and manually read log files to find an anomaly.
Right.
Look at how cybersecurity tools like Darktrace, CrowdStrike Falcon, and Sentinel-1 operate. They mathematically cluster normal network behavior and flag deviations in milliseconds.
Which is necessary, yes.
A ransomware attack moves faster than human perception. You cannot have a human in the loop for the initial defense. The machine absolutely must respond automatically before damage is done. Without this specific AI automation, modern IT infrastructure would literally collapse under its own weight.
Look, I completely acknowledge the power of processing vast amounts of event data. Using AI to parse millions of logs to flag a security threat makes total sense.
Glad we agree on that.
But there is a massive leap from passive analysis to, automated scaling and active deployment. We are seeing AI tools for database management like Superbase AI or Neon that are dynamically optimizing queries and restructuring indexes without human oversight.
To save time and compute?
Yes, but Swati Gupta explicitly cautioned about the inaccuracies inherent in these models.
But human database admins make mistakes too.
Yes, but let's look at how they make mistakes. Imagine an AI hallucination occurring in an automated database management tool. Let's say it misinterprets a spike in traffic.
Okay.
It decides to drop a crucial index to save compute costs, and suddenly your entire cloud architecture cascades into failure.
I see why you think that, but let me give you a different perspective. The risk of an AI hallucination taking down a database is far, far lower than the mathematical reality that human teams simply cannot optimize modern network traffic manually.
I'm not so sure about that.
It's true. Humans make catastrophic errors every single day. A tired engineer runs a script on the wrong cluster. The AI tools are analyzing millions of data points simultaneously to make these optimizations, identifying performance bottlenecks that a human would literally never find.
But when a human engineer makes a mistake, there is a clear chain of causality. We can look at the command history, we can understand the logic, flawed as it may be, and we can implement a specific policy to prevent it from happening again.
You can review AI logs too.
Let me give you an example. If an AI model managing your AWS infrastructure makes a catastrophic scaling decision based on a multidimensional correlation that no human can decipher, you are helpless.
Helpless is a strong word.
In other words, the AI decided to shut down a server because of a tiny temperature spike in a data center in Ohio, combined with a weird traffic pattern in Tokyo. It makes statistical sense to the machine, but to the human engineer trying to debug it at 3 a.m., it's just a black box.
Right, but
You cannot debug a black box that just optimized your production environment into oblivion.
That implies we are just handing the keys over with zero guardrails, which isn't how these tools are deployed in professional environments. You use tools like Datadog AI or MoogSoft to predict the failure, and it sets dynamic baselines.
Baselines that shift constantly.
But it offers the remediation to the human operator first. Or in the case of autoscaling, we set strict parameters. The AI operates within a defined sandbox.
The problem is that the sandbox is getting larger every day, and the foundational understanding of the people supposed to be watching the sandbox is eroding.
I disagree.
If your DevOps team relies entirely on PagerDuty AI or Dynatrace to tell them what is wrong, they lose the intuitive system mapping that comes from manual troubleshooting. They become entirely dependent on the dashboard.
Dashboards are tools.
And if you've ever been in a war room when the dashboard is all green but the system is entirely down, you know exactly that sinking feeling. If the AI is wrong, the engineers are paralyzed.
Well, that brings up something I've been really wanting to dig into. I want to challenge this idea that using AI inherently degrades our understanding,
Okay, how so?
especially when we look at the distinction between traditional machine learning and this absolute explosion of generative AI we're seeing in 2026.
I view generative AI as a massive democratizing force.
Democratizing how exactly?
It requires virtually no massive extra training for a team to use it. Previously, if a company wanted to analyze thousands of online product reviews for software defects, they had to hire specialized data scientists.
True. They had to build, train, and maintain a custom deterministic machine learning model. It took immense time and money. Today, as Ramakrishnan points out in the MIT analysis, they can just use an off-the-shelf LLM like GPT-4, Claude, or Gemini.
Right? They just plug it in via API.
Exactly. It replaces those expensive custom builds, it gets applications running exponentially faster, it democratizes complex data analysis for the entire IT department.
I come at it from a different way because that democratization comes at an incredibly steep cost to accuracy and reliability. We have to respect the technological distinction the MIT Sloan experts make here.
Which distinction?
Traditional machine learning requires labeled data to find and generalize complex correlations. It is mathematically bounded. You give it 10,000 sensor logs, label the ones that crash the server, and it finds the exact mathematical boundary. It is predictive and deterministic.
Right. Generative AI, on the other hand, creates new content. It is fundamentally a probabilistic text predictor.
Right, which makes it infinitely more flexible.
Flexible, yes. Precise, absolutely not. Let me use an analogy here. Traditional ML is like hiring a mathematician to calculate exactly when your bridge will collapse based on stress tests.
Okay, I'm with you.
Generative AI is like hiring a brilliant storyteller who's read every book about bridges and asking them to write a convincing story about when your bridge will collapse.
That's a bit reductive. We are asking a storyteller to do the job of a mathematician. The modern IT professional's dependence on generative AI is becoming a reflexive crutch. Because you can just type a prompt in plain English, developers are throwing LLMs at deep infrastructural problems where traditional deterministic machine learning is actually the effective tool.
That's an interesting point, though I would frame it differently. Fine-tuned generative AI goes much further than traditional machine learning precisely because it isn't rigidly deterministic.
But rigidity is what you want in infrastructure.
Not always. It identifies relationships within datasets that traditional ML simply cannot see, because traditional ML requires strict labels. Professor Gupta herself noted this.
Yes, for novel relationship.
Exactly. Fine-tuned, specific generative AI models can identify novel relationships within data. We aren't just using out-of-the-box chatbots for infrastructure. We are using highly specialized, fine-tuned generative models that combine the vast correlative power of an LLM with the specific, domain-aware strictness of IT operations.
Even a fine-tuned LLM is fundamentally a generative engine. It does not literally know the right answer. It calculates the most likely sequence of tokens based on its training data.
It's highly accurate.
When we talk about database management or cloud infrastructure, we don't want highly probable, we want exact. The danger of 2026 is that the ease of generative AI has convinced an entire generation of developers that probability is an acceptable substitute for precision.
But in complex modern systems, absolute precision is often an illusion anyway. Data is incredibly messy. Network traffic is chaotic.
That doesn't mean we abandon precision.
Traditional ML actually fails when it encounters edge cases it hasn't explicitly been labeled for. Generative models, because of their vast training parameters, can infer intent or identify anomalous patterns that lack strict labels. Look at software testing, for example.
Testing is a great example of where this goes wrong.
Let me explain how it goes right first. Think about how we used to test software. A human wrote a rigid script using CSS selectors like, get element by ID.
Sure, standard Selenium tests.
If a designer moved a button 1 pixel to the left or changed the ID, the entire test suite broke. It was brittle. AI tools for software testing, like Testim or Applitools, completely changed this.
They use visual comparisons.
Right. They use computer vision to evaluate the DOM visually, just like a human eye. They adapt dynamically, the AI adapts to the UI change and keeps trusting the core functionality. That is undeniably a more robust way to build software.
It is more robust, right up until the moment it isn't. Because AI testing tools evaluate visual probability, they lack semantic understanding. It calculates a probabilistic match.
Which is usually correct.
Usually. But if a critical submit payment button accidentally gets swapped with a delete account button, but it looks visually identical in size and color, the AI might pass the test.
Well, that's an extreme edge case.
It deemed the new output close enough to the expected baseline. And because the human QA engineers have outsourced the actual logic of the testing to the AI, they don't even know the vulnerability exists until it hits production and deletes user data.
Okay, I see your point.
This is the core of my argument. When you abstract away the mechanics of the system, you abstract away your control over it.
You're assuming that human QA teams were catching all these bugs before. We weren't. Software has always been buggy. Systems have always crashed.
I'm not denying that.
What these 20 categories of AI tools provide, from data science tools like Jupyter AI to even IT interview prep tools like ThinkGPT, is scale. They raise the baseline of what a single human can achieve in a single day.
But if every single company is relying on the exact same generative models to write their code, test their code, and deploy their infrastructure, we are creating a dangerous monoculture of software architecture.
A monoculture?
Yes. If there is a fundamental flaw or hallucination pattern in the underlying models, whether it's OpenAI's, Anthropic's, or Google's, that flaw isn't just a local bug anymore. It is now baked into the infrastructure of thousands of companies simultaneously. We've traded isolated, predictable human errors for systemic, industry-wide vulnerabilities.
But we have to remember that these models are continuously iterating. The feedback loops are tighter than ever. If a major model outputs a systemic vulnerability, it is patched globally within hours.
Iteration doesn't solve the fundamental problem of human understanding. Let's trace the life cycle of a junior developer in 2026.
Sure, let's trace it.
They use an AI to prep for their IT interview. They get the job. They use an AI to write their code. They use an AI to generate their test cases. They use an AI to monitor their deployments.
And they get a lot done.
But what does that developer actually know? What real value are they bringing to the company, other than acting as a biological API wrapper for a large language model?
They bring strategic vision. They bring the ability to align complex technology with actual human needs, business logic, and user experience, which an AI fundamentally cannot do.
Assuming they understand the tech well enough to strategize.
They do. The human steps away from being a syntax typist and becomes an orchestrator.
They become orchestrators who don't know how to play a single instrument in the band. And when the music stops, they won't know how to fix the instruments.
I think that's a rather pessimistic view of human curiosity, but it highlights exactly why this debate is so important.
It is important.
It's clear that the AI tools across the 20 IT categories we've discussed today, from automated testing with Apply tools to cloud scaling with Azure AI, are fundamentally empowering tools. My position remains that when used correctly, they eliminate manual drudgery.
Fair enough.
They elevate the strategic capabilities of cloud and tech professionals, allowing us to manage systems of unprecedented scale and complexity that would be mathematically impossible to handle manually.
And my position remains that while these tools offer immense short-term productivity and speed, developers and businesses must consciously guard against the erosion of their deep technical expertise.
We have to be careful, sure.
We have to remain deeply vigilant about the hallucinations and fundamental inaccuracies of the underlying models. Because a fast mistake is still a mistake. And in modern IT, a fast, automated mistake can bring down a global network before a human even has time to blink.
Well, I think where we absolutely converge is on the reality of the landscape. AI is everywhere in 2026.
Oh, definitely.
It is absolutely necessary for survival in the competitive IT industry. You simply cannot ignore these tools and expect to keep your job, let alone innovate.
Agreed. Refusing to use AI is not a viable professional strategy. And I think we also both agree with Rama Ramakrishna's core advice from the MIT Sloan analysis.
The point about discernment.
Exactly. The absolute most critical skill for a developer right now is applied discernment. It is knowing exactly when to use a probabilistic generative AI versus when to use deterministic traditional machine learning, or when to just sit down and write the traditional code yourself.
Exactly. It requires continuous auditing of our own workflows. The incredible complexity of the 2026 AI landscape demands that IT professionals master these tools, actively ensuring they do not become mastered by them.
Well said.
Which brings us right back to the cockpit where we started. The autopilot is undeniably a marvel of modern engineering, capable of navigating through storms and parsing telemetry that would overwhelm human senses. It is absolutely essential for modern flight.
When the alarm sounds, the telemetry fails, and the glass dashboard goes completely dark, you still desperately need someone in that pilot seat who actually remembers how to fly the plane.
And perhaps the real challenge of our time is figuring out how to keep those manual, foundational skills sharp when the machine is just so incredibly good at doing it for us. Something to think about the next time you hit Tab to autocomplete that massive function.